Hi friends, today we are gonna do the lab 3.4 in Amazon SageMaker. It will be about separating our data sets, and it will be training sets, validation sets, and test sets. And the work in our lab is about a healthcare provider, and the aim is the detection of abnormalities in orthopedic patients. So this is the same what we have done in lab 3.1 and 3.2, and I think data is same. Let me just start the lab setup. So first of all, we need to import these libraries, and in here Boto3 is the AWS Python SDK, and we will import in addition to other labs. Now let me import these libraries, and in here what we have done the past labs, we imported we get the zip file which contains the data, and we extract this zip file, and after that we are creating and data frames with using Python pandas library. And for our case, the class mapper for abnormal cases, it will be 1, and normal cases will be 0. It means that we are using binary classification. So let me just run these code blocks and run this code. As you can see, the data is right here, and now I will run this code block. Now, as you can see, when I run this, we can see how many samples we have, and how many attributes we have. Actually, we have 6 attributes and 1 for the abnormal and normal cases. So it will be the class at the end. Let me show you like that, which I've showed the earlier labs. Now when we run this column, it will get the title of the columns, pelvic instance, pelvic tiles. These are our attributes, features, and this is the class which we want to detect abnormal or normal by looking at features. Now we are gonna prepare our data. To prepare our data, we want to get this class on the first line. So we're gonna do now. We get this class to first line, and now when we run this code, as you can see, class is appearing in the first. Now we are gonna split our data with using scikit-learn, and this will be for training and validation test. The portion of data will be 0.2, and for the training set we are gonna use the 0.8 portion of the data. And in here it means that the distribution of the abnormal and normal data will be the same portion in test sets and the training sets. And also in test and validate, we are gonna split the train and test is with 0.5. So it means that for training we are going to use 0.8, and for test case we are going to use 0.1, and for validation also we are going to use 0.1. So let me print them out. Actually, I didn't run that logs and that logs. I need to run. Now we can print, I think. Yeah. So for validation we are gonna use 31, and for test case we are gonna use 31, and for training we are gonna use 248 samples. Now let me print them. As you can see, the abnormal cases is 168, and the normal cases is 80 for our training set, and the portion of these and these will be the same, these and these and these and these, as I mentioned earlier. Now after we prepared our train test and validation test, we split and we prepared. Now we are gonna do what? We are gonna upload our data to S3 buckets, and which will do the upload our file to S3 buckets. And as you can see, we send these parameters for training, test, and validate. Let me just run this code and run that code. Now we are importing a Boto tree, and we are getting our image from this XGBoost algorithm, with using this XGBoost algorithm. Now run, and we are gonna set the hyperparams 42, and the eval metric for this area under the curve, and the objective will be binary logistic, which will be 0 or 1. As I say, there is just two cases, normal or abnormal. Now we are creating an estimate object, and we send the container which we retrieve from Amazon XGBoost. We retrieve and we send the container parameters here, and in our case the instance count is 1, so it means that it's not a parallel instance. It is not running parallel. And the instance type is for our case MLM for X large, and the output path S3 output location. This is the final location where our training output will be stored, and hyperparameters we declared in your hyperparams. Now we are creating a training channel and validate channel. We send this train and validation channel to data channel, and we use fit to train our training and validation set. So let me just run these codes, and that codes in here, and that codes. Now when I run that code, it will take, I think it will take a time. Yeah, it's nothing in here. This process can take up to 5 minutes. Let's see. So it's starting to training our dataset, and after this process done, we can see the training jobs in here. As you can see, it's appear already. When it will be done, we can see in here all the details. And I think that's all to explain for that lab. I said everything. Let me check. Yeah, I have mentioned about everything. So uh, see you in the next lab.